All right, what's up, y'all? Midterm review. Let's get started. Identify the points of inflection and discuss the concavity of the function. All right, so what we need to do is we first need to start by finding the second derivative. So I'm going to find the first derivative, of course, first. So the first derivative is 12x minus 5, and then the second derivative is going to be 12. Now, because this is a constant, that means that there's no point of inflection. No point of inflection. And because it's positive, this is concave up from negative infinity to positive infinity. Right there. All right. Now, number two, let's find a second derivative again. So we got the first derivative equals 3x squared minus 8x minus 3. And then the second derivative is 6x minus 8. And so we're going to set that equal to 0. We're going to solve it and divide by 6. And we're going to reduce that to 4/3. So now that we got 4/3, we're going to use the wiggle line test here. All right. So I'm going to try, let's see, 0. And by the way, this is 1 1/3. So we'll test 2. 1 1/3, all right. So we're going to test it in the second derivative. So I'm going to test 0. So 0 minus 8 is negative 8. So that's negative. That's negative. So that means concave down. All right, concave down. Sad face. And then of 2, 12. 12 minus 8 is 4. That's positive. Smiley face. Oh, smile. Oh my gosh, that's a terrible smiley face. Let me try it again. Smiley face. Smiley face. So, what we have here is concave up. Concave up is 4/3 to infinity, and concave down is negative infinity to 4/3. And then our point of inflection is going to be x equals 4/3. All right, let's look at number 3. All right, it says locate the absolute extrema on the function on the given closed interval. Use second derivative when applicable. All right, so let's zoom in real quick. All right, so we need to find the first derivative. All right, which is 3x squared minus 27. All right, now we set that equal to 0. So that gives us 3x squared. You're going to add 27 over here. Divide by 3. And then square root both sides, and you get x equals plus or minus 3. All right, so now I'm going to go to the wiggle line test. And negative 3 and 3. All right, so remember, we got to use these values right here, 0 and 7. All right, so I'm going to do f prime of 0. Plugging in right here. That's negative 27. And that's f prime of 7. And that's going to give us 49 times 3. Anyway, that's positive. All right, that's positive. So what that tells us is that we have a minimum at 3 because you have a decrease and then an increase. So this is a minimum right here at 3. All right, minimum at x equals 3. Now let's do number 4. All right, let's see here, h prime. So I'm going to use u Substitution. I'm going to let the inside equals t minus 3, and u equals 2/3. So f of u equals u to the 2/3. So u prime is 1, and f prime of u is 2/3. U to the negative, you got to subtract 1, so minus 3/3 is negative 1/3. So you have 2/3 u raised to the negative 1/3. Okay. Now we're going to set that equal to 0. Actually, you know what? Let me rewrite this real quick. It'll make solving for 0 a lot easier. There we go right there. Now we're going to multiply by this denominator on both sides. And do that over here. Alright, that's 0. Like that. So you have 2 equals 0. And that's not true. Alright. 2 is not equal to 0. So you got to now look and see what in the denominator will make this 0. Well, 3. If you put 3 right here, 3 minus 3 will be 0. And that'll make this whole thing undefined. Alright, so we're going to test f prime of 4. And when you do that, or negative 4, excuse me, that's going to be a negative. And then we'll do f prime of 6. And that's positive. So that means that there's a minimum and then a maximum. So that means negative 3, or x equals 3. It's a min, a minimum. There's a minimum at x equals 3. Alright, now let's look at this one. It says sketch a graph of the functions having the following characteristics. So let's see here. Let me. So f of 0 equals 0. There's a point at 0, 0. And then f of 4, 0, there's a point. So 4, 0, there's a point. So there's a point here and there's a point here. So for f prime, remember this is increase and decrease, the first derivative. So in this case, f prime is less than 0, so there's a decrease. So when x is less than 0, there's an increase. If x is less than 2, so here's 2, halfway point, there is a decrease up to 2. All right. So right here. And then it says at f prime of 2 equals 0. That means there's no increase or decrease. Remember, the first derivative is increase and decrease. And in this case, there's no increase or decrease. So there's a minimum here. And then for f prime is greater than 0, f of x is greater than 0. If x is greater than 2, so there's an increase right here. And then it just says the second derivative is greater than 0. That means max or min. Since it's greater than 0, it's a minimum. Our graph looks something like this. I don't know how far down it goes, but this is our graph. All right, number 6. A farmer wants to construct a rectangular pig pen using 100 feet of fencing. The pen will be built next to an existing stone wall. So only 3 sides of fencing needs to be constructed to enclose the pen. What dimension should the farmer use to construct the pen with the largest possible area? So let me zoom in real quick. So we got these 2 sides right here. You know what I mean? So we know that area equals length times width, or in this case, x times y. Alright, x times y. And then that's going to be our primary. Our secondary, and we know our primary also because it's find the largest possible area. Alright, and for the secondary equation, we're going to say 100 equals 2x plus y. Alright, because this is 100 feet of fencing right here. And if we got 2x plus y. All right, so we're going to start by isolating y. So subtract 2x. So 100 minus 2x equals y right there. And so we're going to take that, plug it into the primary. All right, distribute the x. So you get 100x minus 2x squared, and then we're going to find the derivative of that. So that's 100 minus 4x, set it equal to 0. We're going to add 4x over there, and then divide by 4, and you get x equals 25. All right, so once you get x equals 25, you come back over here, find y, we plug it in. So you go 100 minus 2 times 25 equals y. That's 50. 100 minus 50 equals y. And when we do that, we get 50 equals y. So this is 50, and these are 25. Man. All right, 7. A rancher wants to construct identical rectangular corrals using 300 feet of fencing. The rancher decides to build them adjacent to each other, so they're share fencing on one side. You're going to share that fencing right there. All right, what dimensions should the rancher use to construct each corral so that together they will enclose the largest possible area? So this is what we got to do right here. Alright, so we can make these short sides x and make these longer sides y like that. Okay, and so remember now we got for the area right here, we got 2x times y because this is x, so this whole side is 2x. All right, and then you got y times y, 2x times y right there. And then we know that we got 300 was it yards? 300 feet of fencing. So we got 4x plus 3y, all right? 4x is 1, 2, 3, 4. 4x plus 3y right there. So we're going to start by isolating y again. So 300 minus 4x equals 3y. Then divide by 3. Divide everything by 3. That's 100 minus 4/3 x. Alright. So I'm going to go over here and plug it in right here. Plug that in right there. Distribute the 2x. So you get a equals 200x minus 8 over 3x squared. So then we find the derivative of that. 200 minus 16 over 3x, like that. And then we set it equal to 0. We're going to add that over right there. So, I'm sorry, 200 equals 16 over 3x, like that. And then we're going to multiply by 3. So 600 equals 16x. And then divide by 16 on both sides. And you got x equals, man, that's 37.5 right there for x. So now I just come back over here and plug it in for y. So to find y, I'm going to go 100 minus 4/3 times 37.5. Alright. So you got 50 equals y when you plug it in. So that's what we got, 37.5 and 50, okay? Alright. Now, this problem right here says find two positive numbers with a product of 12 and the sum is a minimum, okay? So Let me zoom in right here. So we got find two positive numbers. Find two, so s equals x plus y. All right. The sum of two positive numbers and the product. All right. The product equals 12. All right. So we isolate y by dividing by x. All right, and then we're going to take that and plug it into y. Right there. And so we're going to find the derivative of this. All right. And by the way, you can rewrite this as just like that. So we go ahead and find a derivative of that. So you get 1 plus, or actually, it'll be 1 minus 12x to the negative 2, which will take us to 1 minus 12 over x squared, like that. Set it equal to 0. So we're going to first move that to the other side. So you get 1 equals 12 over x squared, and then multiply by x squared on both sides, like that. So you got x squared equals 12, and then we're going to square root both sides, and you get x equals plus or minus, my fault, that was 12. So plus or minus, I'm going to break that down into 4 times 3, which is 2 radical 3. Or, well, we'll leave it like that. Plus or minus 2 radical 3. All right. So that's x. And we want the positive, obviously. We want the positive. We don't want the negative. You see what I'm saying? And so anyway, we just need to find y. So if you go y equals 12 divided by 2 radical 3. And so we do that. Let me see. 12 divided by 2 radical 3. And that gave me 10.4. So y x. Now let's see. It says find the point of the graph of alpha of x equals x squared. That's the closest of the 0.7 and 0.05. Round your answer to the 2 decimal places. So that's what we got. Remember with these problems right here, you need to use a distance formula. But remember, you don't have to focus on the whole equation, right? This is x2 or x minus x1 squared plus y minus y1 squared. All right? You don't have to focus on, again, you can just focus on what you have underneath the radical. So we're gonna use this portion of the equation, okay? So what we do is we plug in our points. We had 7 and 0.5. All right. Oh, my fault. F of x equals x squared. So y equals x squared. So this first one, x squared, x squared, x squared. There we go. Okay. So that's y equals x squared. So that's y1. All right. Anyway, now we need to simplify this. We FOIL that out. So when we FOIL that out, that is x squared minus 14x plus 49. And then we need to FOIL this as well. And when you do that, you get, let's see here, x to the 4th minus x squared plus 0.25, okay? Then we'll simplify it. So let's simplify it. Let's come up here. We get x to the 4th. The x squareds are going to cancel right here. And then you have negative 14x. And then you have plus 49.25. And now I'm going to derive this. So that's 4x cubed minus 14x. Then, as always, we set that equal to 0. 14. Sorry. I'm tripping on the derivative before I do that. That's negative 14. So now add 14 to the other side. Divide by 4. And let's make that 7 halves. And then we will cube root both sides. So x equals the cube root of 7 halves, which is about 1.52. So we take that 1.52 and we're just going to plug it in right here. All right, so you do alpha 1.52. All right, and then that'll give us 2.31 right there. So that's our point. Our point is going to be 2.31 right there. That's our point. That's our closest point right there, okay? All right, let's keep the train rolling. Right here, 3x squared plus 5x minus 12 is continuous on 0, 1 and differentiable on 0, 1. This is the interval from 0 to 1 and differential on 0, 1. All right, according to the mean value theorem, there is at least one x equals c and 0.001, at which f of c equals y2 minus y1. Remember, y2 minus y1 all over x2 minus x1. There you go. I want that to look like a negative. So it says find f of c prime and c. All right, so what we got to do is we need to first find a derivative here. All right, so the derivative right here is going to be 6x plus 5. All right, so we take that. All right, and then what we're going to do is we're going to hold this for a second. And so we're going to the original, and we need to find f of 0. So let's plug it in right here. So we're going to go 3 times 0 squared plus 5 times 0 minus 12 is negative 12. So we got 0, negative 12. And then we got f of 1. 3 times 1 squared plus 5 times 1 minus 12. 3, 5, 8. 8 minus 12 is a negative 4. So we got 1, negative 4. So we got negative 12 minus a negative 4 all over 0 minus 1. That's plus 4. So negative 8 over negative 1 is 8. All right. So we're going to set f prime of c equal to 8. All right, because this is 8. The slope is 8. So we take that. All right. So I'm going to add. I'm going to subtract 5. So 6x equals 3. And then divide by 6 on both sides, and you get x equals 1/2. Or in this case, c equals 1/2. So c equals 1/2. That's what we were looking for right there. We're looking for c. Okay. So c equals 1/2. All right. Now, integration. Let's get on it. We got, I'm going to break this first one apart for y'all just so you can see it done. So the integral right here is going to be x to the, you got to add 1. So 6 over 6 would be 7 over 6. And then divide by 7 over 6. And then for this one, you get 1x. And then plus c. And so I need to simplify that. Keep change flip. So 6 over 7, x to the 7 6, plus x plus c. All right, right there. All right, right here, we got 3x. Oh, I'm sorry. I'm integrating. X to the fourth divided by 4 minus 4x squared divided by 2 plus 2x. And it's divided by 1 because you just add an x, right? Plus c. So anyway, you get 1/4 x to the fourth minus 2x squared plus 2x plus c. And then let's do this one right here. When you have this, guys, just separate it. All right, so you got t squared over t to the fourth minus 3t over t to the fourth plus 2 over t to the fourth. All right, dt, and then I'm going to simplify that even more. I'm going to make this one, let's just do 2 minus 4. We'll do it up here. So 2 minus 4 is negative 2. All right, and then right here, I'm going to do 1 minus 4, so negative 3. 1 minus 4, negative 3. And then move this one to the top so we can have the negative. And this is easier to take the derivative like this, guys. All right. So now let's find the derivative. You get t to the negative 1 divided by negative 1. All right. This one will give you 3t to the negative 4 divided by negative 4. And then this one, we're going to go 2t to the negative 3 divided by negative 3. All right. And I wrote too big, so I need a little space. So right here, you need to move this to the bottom. So remember, there's a 1 at the top. So negative 1 over t. All right. This needs to move to the bottom. So, and then you have a negative, so that becomes a positive. 3 over 4 t to the fourth. And then, oh, I did not mean to do that. And then right here, that becomes a negative, actually. 2 over 3t cubed plus c. So this would be our original function right there. Sorry about that. All right, now number 14 here, it's a definite integral. You could just put that in the calculator. You could go math, option 9. Where am I going from? Negative 4 to 4. And we had 4 minus the absolute value of x with respect to x by 16. So we got 16 for this one. Same thing right here. We're going from 0 to 7. The square root 49 minus x squared right there. There we go. 38.48. And I'm just going to write the answer for this one. You can punch it in and get that answer right there. Okay. All right. Let's jump down here. Find a particular solution. All right. So we've been doing this a lot lately. Okay. When we find a particular solution, so what we first need to do is integrate it. All right. So, well, it's already written out. Well, no, let's write it out. So when we do that, we get 1/5 x squared divided by 2 minus 2x plus c. All right. and that's 1/10. So 1/10. All right. And so we're going to take that and we're going to set this whole thing equal to -10 like that. So we're going to say -10 and then we're going to plug in 10. So 1/10 times 10 squared minus 2 times 10 plus C. So remember with particular solutions, we got to find C. So this is 100. 100 times a tenth is 10. All right, minus 20. And it equals -10. 10 minus 20 is -10. So if you add 10 this way, you get 0. So C is 0, okay? So you come back over here and you plug in your equation. You plug in C and you get 1/10 x squared minus 2x. Since C is 0, I'm not going to put, well here, I'll just put it there so you can see it. Plus 0 equals 1/10 x squared minus 2x. That right there is our equation right there for f of x. That's f of x, okay. 18, this is another particular solution problem, guys. That's all this is. This is the derivative of c, so we're going to say c of x equals the integration of x squared plus 25 dx. All right, when we integrate it, we get x cubed divided by 3 plus 25x plus c. Now what we do is we're going to take that whole thing and we're going to plug in 3 and it equals 108. $25 times 3, sorry. And so that's 27 divided by 3 is 9. This right here is going to be 84 equals 108. And then we're going to subtract 84. And when we do that, that is going to give us 24. 24 is C. So we just plug it in. We plug in our function right here with our C for our particular equation or particular solution. So you got x cubed over 3 plus 25x plus 24. And that's our function right there. All right, right here it says find the average value of the function f of x equals 48 minus x squared over the intervals of -2 to 2. This is just a definite integral equation right here. All right, but you use this equation right here, 1 over b minus a times the definite integral of a over b f of x dx. So you have 1 over 2 minus 2, or 2 minus a -2, sorry. 2, hold on, 2 minus -2. Like that. Let me make sure, -2 to 2, yep. Integrate from -2 to 2 of 48x, 48 minus 12x squared dx. Right there. And so this is 1/4. And then you find a derivative right here. Math 9 -2. You know what? You could really put this whole thing in your calculator. So 1/4 times math 9 from -2 to 2 48 minus 12x squared. Oops. Right there. And there we go. We got 32. All calculator work. So 32. All right. My favorite problem of the day right here. A ball is thrown vertically upward at a height of 8 feet with an initial velocity of 65 feet. How high does the ball go? So you got to find a height right here, guys. Remember, we start with negative 32 and work backwards from there. So, we work backwards from here. Remember, this is 32, so we're going to integrate that. And when you integrate that, you get 32x plus c. Well, the initial velocity was 65. So now c, and by the way, this is the first derivative. This is h prime. So right here we got 32x plus, oh, that's a negative. My fault, you start with negative 32. There you go. So that's negative 32x plus 65. I forgot. I'm sorry, y'all. It's negative 32. Add that in. You start with negative 32. Negative 32. All right, don't forget that. So then I need to integrate that one more time to get h. All right, the original function. So negative 32x plus 65 dx. And so when we integrate that, we get negative 32x squared divided by 2 plus 65x plus c. And that's going to give us our height right here. So h equals negative 16x squared plus 65x plus 8 right there. All right, and so we set that equal to 0. That equation that we found, all right, so h, well, we're going to make it 0, okay? Like that, and then we're going to solve this. You're gonna have to do the quadratic formula right here, okay, y'all? So we're gonna say x equals 65 or negative b plus or minus the square root of b squared minus 4 times a times c, and put this whole thing all over 2a. All right, my advice: do the top first, then the bottom. All right, but when you plug that in, you get x equals negative 0.12 and x equals 4.2. All right, there you go right there. Negative 1.2, negative 0.12, sorry, and 4.2. Which is where I got those numbers from. So you don't want a negative, right? You want a positive height. So 4.2 is our answer right there. All right. Let's see here. All right. A sample contains 3.5 grams of radium after 10,000 years. Radium has a half-life of 1,599 years. Determine the initial quantity of radium. All right. So remember, we use this equation right here. I'm sorry. Y equals C e to the kt. All right, where c is the initial value, which is what we're looking for in this case. K is your constant proportionality, sorry, I had to sound that out, and t equals time. All right, t is time. So let's go ahead and solve it. All right, so in this case, let's look at what we know again. In this case, we know that it contains 3.5 grams of radium after 10,000 years. All right, and then it has a half-life of 1,599 years. Determine the initial quantity. All right, so what we're going to do is, we know we're going to have 1/2 of C. So since we know we're going to have 1/2 of C, oops, I didn't mean to put 1 over C. I meant to put 1/2 C. All right, and 1,599 years. So I want to start by finding K. And so I'm going to divide by C on both sides. All right, so I got 1/2 equals E to the K, or let me rewrite this, 1,599 K. And so now I need to get rid of E, so I'm going to natural log both sides. That's the inverse of E. So you get ln 1/2 equals 1,599K. And so now if you divide by 1,599, all right, that'll give you your K. This is K, guys. My handwriting's terrible. But K equals this right here. And so let me punch that in my calculator real quick. You get K equals 0.0004335. Like that. And so now that I have K, I can figure out a sample contains 3.5 radium after 10,000 years. Determine the initial amount of radium. So I know I got 3.5 grams of this stuff. Radium. Negative 0.0004335 times 10,000. Right there. So we can find this initial value right here. And all I'm going to do is divide both sides by this e to the negative 0.0004335. And you do it over here to divide this over here. This on this side. So when you punch it in your calculator, and I'm going to do it right here so you can see it. We're going to do 3.5 divided by, well, I don't need to do that. Sorry. Divided by E. My goodness. Okay. 3.5 divided by E to the negative 0.0004335 times 10,000. Okay. And we get 267.14. 267. 14 grams of radium is what we started with. Okay. All right. 42 minutes in. I am done with the review, and I hope this helps.